Hi, my name is Gina Porter, and I'm the math specialist at Rock Prairie Elementary. And for the next few minutes, we're going to talk about fourth grade math and what the students will be doing during the second 9 weeks, specifically what they'll be doing with division. And if you kind of look at an overview of the second 9 weeks, they began the year with a lot of work with fractions and decimals, and that rolled over to the beginning of the second 9 weeks as they worked on adding and subtracting fractions with like denominators. And now they're understanding and applying multiplication and division. And this section really kind of focuses on division. There's a different video that talks about all the models of multiplication. So when they're working with division, it's really a big part of the focus is working on how you can represent those problems and different models that you can use. One of the models is this area model. So if we wanted to divide 1,293 divided by 6, because they divide up to 4-digit numbers by a 1-digit number. So when we look at this, what we're thinking is, I'm trying to see how many groups of 6 I can make out of 1,293. So we put the 6 over here because we're thinking, how many groups of 6 can I make? And since our students are really good at multiplying by 10 and by 100, they're thinking, could I make 100 groups of 6? Well, yes, I could. That's 600. In fact, I could make 200 groups of 6 because that would be 1,200. So inside the box here, that is a 6 by 200, represents 6 by 200. They say, well, I started off with 1,293. When I multiply 200 times 6, I'm using up 1,200. And if I subtract, that leaves me with 93. So now I have 93, and I'm thinking, how many groups of 6 can I make out of that? So they're going to think, oh, I can make 10 groups. And if I make 10 groups of 6, that's 60. So I still have 93 left. I multiplied 10 times 6, and that uses up 60. And when I subtract that, now I have 33 left. So how many groups of 6 can I make out of 33? Well, I know I can make 5 because 6 times 5 is 30. So I have 33. When I multiply 6 times 5, that is 30, uses up 30. And when I subtract, I have 3 left. If I have 3 left, can I make another group of 6? No, I don't have enough. I only have 3. So then I look at how many groups I've made. I made 200 groups, then 10 groups, then 5 groups. So I made 215 groups of 6, and I had 3 left over. So my answer is 215 with a remainder of 3. And this is called the area model. Here's another example of an area model. And again, you see they were dividing 976 by 8. So how many groups of 8 can I make out of 976? And they go through the same process. I can make 100, which used up 800 and left me with 176. I still have 176, and I think, oh, I could make 10 groups of 8. That uses up 80, and that left me with 96. I still have 96, so I'm going to make another 10 groups of 8, which uses up 80 and leaves me with 16. Now I have 16 left. I could make 2 groups of 8, and that uses up 16, and I have nothing left this time. So my quotient is 122. And we want to use the correct terminology for division with our students. The number that we are dividing is called the dividend. The number we're dividing by is called the divisor. And the answer to a division problem is called the quotient. Here's an array, which is similar to the area model, but now if we say we're making a group of 80 or a group of 40, there are actually 40 different spaces inside here. So 127 divided by 4. How many groups of 4 can I make out of 127? So I'm making groups of 4, and you can see on the side there are 4 rows, column of 4, and I'm going to make 10 groups. So I have 10 squares across here. So it's a 4 by 10 rectangle, and 4 times 10 is 40. So now instead of recording it in the boxes, we're coming over here and recording it a different way. I have 4 as the divisor. I'm making groups of 4. I have 127 to start with. I decided I could make 10 groups of 4, and that used up 40. So I can see it visually over here, and I'm recording it over here. So when I use that 40, now I have 87 left. So I decided I can make another 10 groups of 4, and I recorded that here, and that used up 40. So I can see it in a visual model here, and I'm recording it over here. So when I use up this 40 out of the 87, I have 47 left, and I think I can make another group of 10 groups of 4. So here's another 4 by 10 rectangle. I can see that visually. And then I'm going to record. I made 10 more groups of 4, and that used up 40 of the 47 spaces I have left. So when I subtract, I have 7, and I think, can I make another group of 4? Yes, I made one more group of 4. So I made the notation that I used one group of 4, and that used up 4 more. And when I subtract, I see I have 3 left. So if I have 3 left, can I make another group of 4? No, I don't have enough. So this is my remainder. So I add up all the groups I made. I made 10 plus 10 more plus 10 more, which is 30, plus 1 more is 31. So I made 31 groups of 4 with a remainder of 3, with 3 spaces left over where I couldn't make another group of 4. This is the same process, just, so that you can look at another example. This time we have 242, and we're splitting it up into groups of 7. So we have 7 rows, and then you can see, we made 10 groups of 7, 10 more groups of 7, 10 more groups of 7, 4 groups of 7, and then we had 4 left over. And so we recorded that over here, and we drew a picture on graph paper. If you want to have some graph paper so your child can practice drawing arrays like this at home, if you Google free printable grid paper or free printable graph paper, there are several good websites where you can go in and print graph paper where the squares are many different sizes. You choose what works for whatever you're doing. So when they're solving division word problems, sometimes there are remainders. And so they have to think about what to do with those remainders. What does a remainder mean? And there are different kinds of questions that are asked. Sometimes the answer turns out to be the quotient plus 1 more. Sometimes the remainder is the answer. And sometimes the answer is the quotient without the remainder. So let's look at some examples. Here's a problem. The 4th grade is taking a field trip. They need to rent minivans to get there. There are 125 people going. Each minivan can hold only 8 people. How many minivans do they need to rent? So they're taking the 125 people and splitting them up into groups of 8. And we see that we can make 15 groups of 8, and we have 5 left over. We have a remainder of 5. So then we have to think, how many minivans should we rent? Well, we know that we need 15, but when we fill up 15 minivans with 8 people, we're going to have 5 people left over. Well, those people want to go on the trip too. So then we have to take the quotient and add 1 more to it. So the answer would be that they need to rent 16 minivans so that everybody has a place to sit. In this one, the answer is the quotient without the remainder. The 4th grade is taking a field trip. They need to rent minivans to get there. There are 125 people going. Each minivan can hold only 8 people. So we've got the same information, but the question is different. How many minivans will be completely full? So again, if we divide 125 into groups of 8 people, we have 15 full minivans with 5 people left over. So our answer is that 15 minivans will be completely full. So we're ignoring the remainder and just talking about the groups that we completely populated with 8 people. And here the answer is the remainder. Basically the same kind of information. The 4th grade is taking a field trip. They need to rent minivans to get there. There are 125 people going. Each minivan can hold only 8 people. They have rented 15 minivans, and the rest will go in a car. How many people will ride in the car? So if we divide 125 by 8, we see we have 15 full minivans, and we have 5 left over. So those 5 people left over are the ones that are going to ride in the car. So just the remainder, just those 5 people left over, and that's what answers the question. They also estimate solutions. That could be for addition, subtraction, multiplication, or division. They can round the numbers, or they can use compatible numbers, which are just friendly, easy to use numbers that are close to the quantity that we're starting with. Clara has 354 stickers. She's going to put the stickers on 6 pages in her sticker book. What is the best estimate of the number of stickers that she will put on each page? Well, we could round 350 off to the nearest 100, but that would round up to 400, and 400 is quite a ways from 354. So I probably would not want to do that. I could round 354 to 350, and that would be rounding to the nearest 10. But 6 does not divide evenly into 350. Then I think, well, 360 is pretty close to 354, and 6 does divide evenly into 360. So 360 would be considered a compatible number. It is a number that is close to the original quantity, close to 354, but easy to work with because 6 divides evenly into 360. And when we're estimating, there are usually many roads to take to do an estimate. It's whatever makes sense to the person who's doing the estimation. If they're answering a question, it's multiple choice, and they have to look at the answer choices and kind of let that help them, guide them. You know, they are going to do the standard algorithm. They are going to divide up to 4-digit numbers with, 1-digit divisor with the standard algorithm. But that does not mean that they don't need to understand and be able to work with all the representations. Because, as I said earlier, sometimes the answer choices are matching an equation to the correct representation. And we need to not convey to the students that the standard algorithm is the real math, and then we just do this other stuff that doesn't really matter. The representations really do matter, and it's helping to set them up to be successful in later math classes, especially algebra and beyond. And it is real math. Real mathematicians do many visual representations to help them understand the situation and know what's going on, to help them organize their thoughts. They also work with input-output tables. Sometimes the numerical expression is where they have to multiply. Sometimes they have to do division. And, if the input here was 23, we would have to multiply it times 4 to get the output. If we were given the output, then we would have to do the inverse. We would have to divide the output by 4 to get the input. Here's another example. Well, thank you for watching. I hope this helped. If you have any questions about this or any other math topic, you are free to give me a phone call here at the school, or you can reach me via email at jporter@csisd.org. There'll be another Math for Parents for the third 9 weeks on January 5th, 2017, and another set of videos on our YouTube channel. Again, thank you for watching.